Uh, am I audible now?
Better.
Okay, sir, Dr. A.K. Agrawal, sir, you are live. Please start.
Okay. Hello, friends. Good morning. So, I'm Dr. A.K. Agrawal, presently working in Vishweshwaraya National Institute of Technology, Nagpur, in Department of Mining Engineering. And today I will be having an interactive session on numerical based on mining machinery. Yeah. And today I will cover those problems which are already asked in GATE examination. So you will get an idea what different type of questions are asked in GATE examination related to mining machinery and how to attempt those questions in minimum time. So I will take one by one each and every question, and in 1 hour time I will try to cover as many questions as possible. So let us start. So I'll take first question which was asked in GATE 2017. It was a very easy and simple question. A double-ended ranging drum shearer is employed in a longwall mine of face length 150 meter. The mining height is 3.5 meter and depth of the web cut is 0.76 meter. The cycle time for unidirectional cutting is 40 minutes. Considering density of coal to be 1.4 ton per meter cube, coal production per cycle from the face in tons is. So what he is asking, in one cycle is completed in 40 minutes. So in 40 minutes, how much coal will be produced? If height of the face is 150 meter, length is 150 meter, and depth of the cut is 0.76 meter. So very simple question, and the straight question doesn't need any much assumption, etc. So this is the production per hour from a shear. 60 H as VH into gamma. H is height of the seam, it is 3.5 meter. What is S? S is the depth of the cut, it is 0.76 meter. VH, haulage speed, that is, it completes 150 meter in 40 minutes. So 150 upon 40 meter per minute, and gamma is the density 1.4. So let us put all these value here. Haulage speed is 150 upon 40 meter per minute because it cuts 150 meter in 40 minutes. So haulage speed is 150 upon 40 meter per minute. Let us put all these value here. 60, height of the seam is 3.5 meter, depth of the cut is or web cut is 3.76 meter, haulage speed is 150 upon 40 and density is 1.4 tons per hour. In 1 hour this much will be produced. In 1 hour this much will be produced. If I simplify it, I get 837.9 tons per hour. But he is asking in 40 minutes coal production per cycle, and one cycle is completed in 40 minutes. So in 1 hour this much is produced. In 40 minutes how much coal will be produced? So 60-minute production is 837.9 ton, and 40 minutes production will be 837.9 into 40 divided by 60. This is equal to 558.6 tons per cycle. This is the answer. So a very simple and straight question, and I think all of you got this. Very simple. Okay, I'll take another question. A coal seam of 2 meter thickness is extracted by a longwall panel with face length 120 meter. Seam thickness 2 meter, length is 120 meter, web depth of shear is 0.6 meter. Average manpower in the longwall face in a shift is 20. 20 persons are working at longwall face. The specific gravity of insitu coal is 1.4. If the shearer makes 4 full cuts in 3 shifts, the phase OMS in tons is OMS, output per man per shift. In one shift, one person is producing how much coal? So 20% manpower is 20 per shift. Face length 120, thickness is 2 meter, web thickness is 0.6 meter, density is 1.4. If shearer makes 4 full cuts in 3 shifts, so total production of the shearer. First let us count that. Just production per day. production per day 2 meters seam thickness, 120-meter length, 0.6 meter web thickness, 1.4 is the density, है ना? 1.4 is the specific gravity. 1.4 is the specific gravity as compared to the, it doesn't have any unit. So if we multiply it by 1000, you will get tons per meter cube, 1.4 tons per meter cube into 4, because 4 such cuts are there in one day. In one day, 3 shifts are there, and in 3 shifts, 4 cuts are there into 4 tons per day. Tons per day. So if you simplify it, it is 806.4 tons per day. In one day, 806.4 ton production is there, and average manpower in the longwall phase in a shift is 20. In one shift, 20 persons are working. So production per shift, because 3 shifts are there in a day, 806.4 divided by 3, 268.8 tons per shift. This much production is there in one shift, and in one shift, how many persons are working? 20. So OMS is 268.8 divided by 20. This is equal to 13.4. So each and every worker working in underground at longwall phase is producing about 13.44 tons. So just here, what you can do here, you are getting 806.4 ton per day. And in one day, how many workers are working? 3 shifts are there. Total 3 shifts. In each shift, 20 persons are working. So in one day, how many persons are working? 60. So straightway you can do here 806.4 divided by 60. You will get OMS. Again, you will get the same answer, 13.44 tons. Okay. So this was another problem. I'll take another problem on shearer. One more problem on shearer. A shearer is deployed in a mine where the specific energy consumption for cutting coal is 800 kilojoule per meter cube. To cut the coal, specific energy consumption means energy used for cutting unit weight of coal. So the specific energy consumption for cutting coal is 800 kilojoule per meter cube. To cut 1 meter cube of coal, 800 kilojoule energy is used. The specific gravity of in-situ coal is 1.2. If the machine produces 700 tons per hour, the electrical power consumption in kilowatt of the shearer is at 65% motor efficiency is. So how much electrical power consumption will be there in kilowatt if this is the given data? So first, it is given production is 700 tons per hour. 700 tons per hour. So let us find out production in meter cube per hour. This divided by density. Density unit is tons per meter cube. So if you divide it by 1.2, you will get production in meter cube per hour. This much, because we are having energy in terms of meter cube. Energy meter cube. Now just remember one thing, one basic interesting fact I will tell you. Whenever you want to calculate power consumption, power consumption is watt. Remember, power is calculated in watt. Watt is work done per second or joule per second. Remember that, joule per second. Kilojoule per second means kilowatt. That's all. So you have to find out the kilojoule per second. Here it is kilojoule per meter cube. Just remember this basic. Anyway, so production is 583.33 meter cube per hour. In 1 hour, this much coal will be produced. Per second divided by 60 into 60. This much coal will be produced per second. Per second, this much coal will be produced. Okay. 0.162 meter cube per second. Per second, this much production is there. And for 1 meter cube of coal, 800 kilojoule energy is used. So power is equal to 0.162 meter cube. This much meter cube per second production is there into 800 kilojoule per meter cube. Meter cube, and so it becomes 129.6 kilojoule per second. This is power, kilojoule per second. Kilojoule per second means kilowatt. So it is 129.6 kilowatt. But its efficiency is only 65%. Its efficiency is only 65%. So motor power is equal to 129.6 divided by 0.65 is equal to 199.4 kilowatt. So even though 129 kilowatt power is required to cut the coal, but motor is not working at its full efficiency. Its efficiency is only 65%. Its efficiency is only 65%. So that is why more power will be required at the motor. So motor power of 199.4 kilowatt is required to cut this much coal. Okay, to produce 700 tons of per hour of coal. Okay, let us switch over to another question. In a short wall panel, coal is extracted from the face by a continuous miner having rate of production 30 tons per hour. Continuous miner is working with production rate 30 tons per hour. Coal having a specific gravity of 1.4 is transported by LHDs of capacity 0.9 meter cube each to a feeder breaker located at 60 meter from the face. If the average speed of LHD is 0.5 meter per second and total loading and unloading time of LHD is 40 seconds, the number of LHDs required to match the production of the continuous miner is. So how many LHDs will be required to deal with production rate of 30 tons per hour? So first let us calculate cycle time. In every cycle, what is the capacity of LHD? How much it can produce? In 1 hour, how many cycles are possible with one LHD? That will give us number of LHDs required. It's basic concept. It was asked in GATE 2015. It was asked in GATE 2015. So, okay, I think you got the question. You can go once again the question and then we can start. So first let us find out the traveling time of LHD because we want to calculate cycle time of LHD. So for that, traveling time of LHD is required. Traveling time of LHD is because total how much traveling time is there? One side distance is 60 meter. So 60 loaded will go to the feeder breaker and again it will come back to the face with 60 meter travel. So total travel distance is 60 plus 60 120 meter. But its speed is zero point 0.5 meter per second. 0.5 meter per second. So this divided by 0.5 is equal to 240 seconds. So traveling time of LHD is 240 seconds. Okay. Loading and unloading time of LHD is 40 seconds. So for loading and unloading, minimum time is 2 seconds are required. So it is 40 seconds. So cycle time for LHD is 240 plus 40 is equal to 20 seconds. Tell me this is clear, I think. Cycle time for LHD is 240 plus 40 is equal to 280 seconds. Okay. Now number of cycles in 1 hour. In 1 hour, 60 minutes, 60 seconds. So 1 into 60 into 60 divided by 280 is equal to 12.85 cycles are there. Number of cycles in 1 hour are 12.85. Handling capacity of LHD in 1 hour. Now in 1 hour, 12.85 cycles are there. Capacity of each bucket is 0.9 meter cube, 0.9 meter cube, and specific gravity is 1.4. Specific gravity is 1.4. This much tons. This much tons. Is equal to 16.2 tons. So in 1 hour, one LHD can handle 16.2 tons. In 1 hour, one LHD can handle 16.2 tons of coal. But coal production is 30 tons per hour. 30 tons per hour. So how many LHDs will be required? So number of LHD required for 30 tons per hour is equal to 30 divided by 16.2, but number of LHD cannot be in fraction. It will come 1.9 or 8 something, but it cannot be in fraction. So number of LHDs required will be 2. So 2 LHDs will be required to handle 30 tons of coal production in 1 hour. Okay, this question was asked in GATE 2015. So here answer is 2. Answer is B. Okay, this question was asked in GATE 2018. Let us see again. An SDL of 1 ton capacity operates with a cycle time of 6 minutes. So 1 ton capacity of SDL cycle time is 6 minutes. The dimension of the face is 4 meter by 3 meter. Face dimensions are 4 meter by 3 meter. 5 blasts are conducted per shift with an average pull of 1.2 meter. If the density of blasted coal is 0.8 ton per meter cube, the time required by the SDL in the shift to lift all the prepared coal in hours is. So how much time will be required by an SDL to load all the coal? To load all the coal. So first let us find out how much coal is produced. How much coal is produced in one shift. Okay. So phase dimensions are 4 into 3 meter, 4 into 3 meter, and average pull is 1.2. So coal production per shift 4 into 3 into 1.2 into 5, because 5 blasts are conducted. 5 blasts are conducted per shift into 5. Meter cube, this much meter cube is equal to 72 meter cube. So 72 meter cube coal is being produced in each shift. Okay. Now how much coal is transported by, this is in ton. Okay, if you want to convert in ton, because density of blasted coal is 0.10 per meter cube, so 0.8 tons per meter cube cancel, so it becomes 57.6 tons. Cycle time, it is given 6 minutes. Cycle time of SDL is 6 minutes. Now let us calculate the capacity. Capacity of SDL is 1 ton. So number of cycles required for coal produced per shift was 57.6 tons of coal being produced. In one cycle, SDL transports only 1 ton of coal. So 57.6 divided by 1 is equal to 57.6. So 57.6 cycles are required. Okay. Time required by SDL. Yeah, how much time will be required by SDL? 57.6 into 6, because each cycle takes 6 minutes. Because number of cycles 57.6. This is equal to 345.6 minutes. So time required by SDL to load complete coal produced in the shift is 345.6 minutes. This divided by 60, you will get in hours, that is 5.76 hours. So one single SDL will load the complete coal in 5.76 hours. Okay. The following data The following data are provided for a surface mine to be excavated by a shovel. Production target 10,000 tons per shift. Average hours per shift 6. Shovel loading time per hour 106. Cycle time. Loading cycle time per hour 106. Bank density of the material mined 2400 kg per meter cube. Bucket fill factor 0.64. Swing factor at 120 degree swing 0.91. Utilization of available time 83%. Number of working days in a year 300. Number of shifts per day 3. Now, based on this data, two questions were asked. The annual production target in million ton is per year how many million tons of coal will be produced? Second, the size of bucket of the shovel in meter cube is what will be the size of bucket so that this much production can be handled. Okay, let us take the first part. A very easy and straight question. The annual production target is this is 10,000 ton per shift. In one day, three shifts are there. And total how many working days are there? 300. 300 working days and number of shifts per day 3. So 10,000 into 3 per shift production into 3 per day production and 300 days in 1 year. So annual production target is equal to 90 lakhs tons, 90 lakhs tons or 9 million tons per annum. Answer is D. 9 million ton per annum. This is the annual production. Okay. Now in second part he is asking the size of the bucket to handle this much production. Okay. Let us assume size of the bucket. Let size of the bucket is B meter cube. Now using this bucket, how much can be produced? How much we have to produce? 9 million ton. We have to produce 9 million ton using this bucket. So what will be the capacity of the bucket? So chaliye, production per annum is equal to bucket loading capacity per annum. How much this bucket can load in 1 year? And in 1 year, how much production is targeted? 9 million. Okay, let us put all these values. It's very straight. 9 million ton is equal to B is the bucket capacity. B is the bucket capacity. Now, shovel loading cycle per hour. Loading cycle in 1 hour, how many loading cycles will be there? 106. 106 loading cycles. Okay, but in 1 hour. In 1 hour. In one shift, how many hours are there? 6. 6 hours. And how many shifts are there? 3. 3 shifts are there. In 1 year, how many days are there? 300 working days are there. Okay, this is the time frame. 2.4. What is 2.4? This is the density. Density of the material is 2400 kilogram per meter cube divided by 1000. So it is 2.4 tons per meter cube. Fill factor 0.64. Swing factor at 120 degrees swinging 0.91 because capacity will decrease and utilization of available time is 83% in 0.83. So let us go one by one. Production per annum is 9 million ton. This is 9 ton. Okay. B is the size of the bucket. 106 is the shovel loading cycle per hour. In 1 hour, how many cycles are there? 106 in 1 hour. 106 cycle. In each cycle, he will produce B ton, B meter cube. In one cycle, shovel will produce B meter cube. And how many cycles are there in 1 hour? 106. In one shift, how many hours are there? 6 into 6. How many shifts are there in one day? 3. into how many days are there in 1 year? 300. What is the density of coal? 2.4. 2400 kilogram per meter cube in ton per meter cube, it will be 2.4 tons per meter cube. Bucket fill factor 0.64. 0.91 is the swing factor of shovel bucket 0.9. And utilization of available time is 83%. Now in this equation, if you see, only one unknown is there, that is B. Each and everything is known to us. Only one unknown parameter is there, that is B, means bucket capacity. So just let us simplify this. B is equal to 13.55 meter cube is the answer. So D is not. Okay, so this was another type of question. Now let us move towards another question, which was asked in 2014. Year 2014. A dragline is required to remove 3 lakh meter cube of rock per month on the bank volume basis. Considering the following data for the dragline, effective working hours per month 450, 450 working hours in 1 month. Bucket fill factor 0.8. Cycle time 65 seconds. Swell factor of the rock. Means if you break the rock, its total volume will increase. Volume will increase means density will decrease. So swell factor, how much it will swell or how much its volume will increase. The swell factor of the rock is 1.25. The minimum bucket capacity of the dragline in meter cube is. What will be the bucket capacity of the dragline to remove 3 lakh meter cube of rock per month under the given set of conditions? Okay, so let us calculate effective volume of rock. This is 3 lakh meter cube, but swell factor is 1.25. So total volume of the rock will be 3 lakh into 1.25 is equal to 375 meter cube. Number of cycles per month. In 1 month, how many cycles will be there? In 1 month, 450 hours are there. 450 hours into 60 minutes into 60 seconds, and one cycle time is 65 seconds. You understand? So you will get number of cycle in 1 month. This is equal to 24923.07. So number of cycles in 1 month we got. In one cycle, how much will be the production? Production per cycle 375 is 0 divided by 24923.07. So this is the production per cycle is equal to 15.046 15.046 meter cube. This is the production in one cycle. Let C meter cube is the bucket capacity because we have to calculate the bucket capacity of the dragline. So production per cycle will be C into zero point 0.8 because bucket fill factor is 0.8. Only 80% will be filled. C into 0.8 production is equal to C into 0.8. This is the production per cycle. This is the production per cycle. So 15.046 is equal to C into 0.8. So you will get C is equal to 15.046 divided by 0.8. This is becomes 18.8 meter cube answer. 18.8 meter cube answer. Because the minimum bucket capacity of the dragline in meter cube is in meter cube 18.8 meter cube. Okay, so now let us go to another problem. A 15-yard cube dragline is deployed in an overburden bench of an open cast mine. It works for 40 days at a rate of 6 hours per shift and 3 shifts a day. The cycle time, bucket fill factor, and operating efficiency of the dragline are respectively 50 seconds, zero point 0.8, and 75%. The total volume of overburden in meter cube handled by the dragline is 1 yard cube is equal to 0.765 meter. So total volume of overburden in meter cube. That is. Okay. So total working time is how much? 40 days. 6 hours per shift. 3 shifts a day is equal to 720 hours. So your drag line worked for 720 hours. Okay. Is equal to 720 into 60 into 60 seconds is equal to 259,200 seconds. And what is the cycle time? 50 seconds. So number of cycles, total number of cycles 295 which is 0 divided by 50 is equal to 51,840. These cycles will be carried out by the dragline. Okay. Now production per cycle, bucket capacity is 15 yard cube and 1 yard cube is 0.765. 0.765. So इसको बाद में दिया मैंने. 0.8 is the bucket fill factor. Bucket fill factor is 0.8. Only 0.8, 80% will be filled, and operating efficiency is 75%. So 0.75, 75 into, to convert this yard cube into meter cube, 0.765 meter. So it becomes 6.885 meter cube. So in one cycle, this much, this will be the production, this will be the production, and total number of cycles are this much. So total volume of overburden is 51840 into 6.885 meter cube. This is equal to 3,56,918 meter cube. So total volume of overburden to be removed 356,918 meter cube. 356,918. This is done. Okay. Now, just this is another type of question which was a very interesting question. It was asked in GATE 2015. GATE 2015. A loaded dumper of total mass 75 ton, having wheel diameter 1250 millimeter, runs on a haul road which offers an average specific rolling resistance of 260 Newton per ton. The engine develops an axial torque of 15 kilonewton per kilonewton meter. The starting acceleration of the dumper in meter per second square. You have to find out the acceleration of the. So torque, we know torque is equal to force into radius. Torque is equal to force into radius. Torque is, engine develops an average axial torque of 15 kilonewton meter. Means 15,000 Newton meter. Force is, we have to determine how much force is developed, and radius of the wheelbase is 1250 millimeter or 1.25 meter. and radius will be 0.625 meter. So force into radius is equal to torque. So force developed by the dumper is 24,000 Newton. So this dumper will generate this much force because remember that he is asking acceleration. Acceleration is force. Force is equal to mass into acceleration. Force into mass into acceleration. चलिए let us see. Rolling resistance is equal to 260 into 75 because weight is 75 ton and rolling resistance is 260 Newton per ton. Now if this is the dumper, suppose this is the dumper. In this direction force is acting. Rolling resistance will act opposite to it. Rolling resistance will act opposite to it. So force minus rolling resistance is equal to mass into acceleration because this minus this is the total force which is effectively working on this dumper due to which dumper is moving in this direction. In the direction of force, then only acceleration. This is the resultant force F minus rolling resistance is equal to mass into acceleration. So now here if you see F is known to you, rolling resistance is known to you, mass of the dumper is known to you 75 ton, only acceleration is unknown. So let us put all these values. F is force is 24,000, rolling resistance is 260 into 75 is equal to M 75 ton means 75,000 kg into acceleration in meter per second square. Into acceleration in meter per second square. So if we solve this equation, you will get value A is equal to 0.06 meter per second square. So it was a different type of question, but very interesting, very simple. Okay, now let us proceed to another question. A bucket wheel excavator with 20 buckets of capacity 0.5 meter cube each. 20 bucket capacity of each bucket is 0.5 meter cube. Rotates at 5 revolutions per minute. Yeah, bucket wheel excavator, its wheel is rotating 5 revolutions per minute. The bucket fill factor of 80%. The excavator loads onto 1200 millimeter wide belt conveyor. It loads on a belt conveyor which is 1.2 meter wide. The cross section area in meter cube of the material on the belt is 0.1 B square. When material is loaded on the belt conveyor, it occupies some cross sectional area. So that area is 0.1 B square, where B is the belt width in meter. The minimum speed of the belt in meter per second to avoid spillage of the material is what will be the speed of the belt. So first let us calculate how much is the capacity of bucket wheel excavator. Bucket wheel excavator capacity per minute is equal to 0.5 each bucket capacity, 20 buckets into 20 buckets, number of rotation 5 into 5 rotation, and bucket fill factor is 80% into meter cube per. This much will be the production by bucket wheel excavator per minute, that is 40 meter cube per. In 1 minute, 40 meter cube coal or rock will be produced. Okay. That is in per second divided by 60 is equal to 0.6667 meter cube per second. Now belt carrying capacity, because if you see cross section of the material on the belt is 0.1 B square where B is the belt width into velocity, in velocity means meter per second. So this much, this is meter square, into meter per second, it becomes meter cube per second, that will be the capacity of the belt. In meter cube of rock per second or meter cube of coal per second. So let us put all these values here. V we have to determine per second, and this is the bucket wheel excavator. Both should be same. Both should be same. So 0.0067 is equal to 0.1. B is the belt width is 1.2 meter cube, 1.2 meter. which is 1.2 meter square. V square is okay, and V is the velocity which we have to determine. Simplify this, you get the answer. V is equal to V is equal to 4.63 meter per second. So C is the right answer. This question was asked in GATE 2013. Okay, let us take another different type of problem. Surface miner. A surface miner with 2 meter cutting drum width excavates coal in windrowing mode from a bench with effective face length 200 meters. Effective face length 200 meters. The cutting speed of the surface miner is 10 meters per minute and the cutting depth 25 centimeters. The density of coal is 1.4 ton per meter cube. If the average turning time of the machine at the face end is 5 meters, the rate of production in ton per hour becomes. So you have to find out production rate per ton by using the surface mode. Width is 2 meter and face length is 200 meter. So cutting time will be how much? Because face length is 200 meter and speed is 10 meter per minute. So cutting time will be 200 divided by 10, 20 minutes. So it will take 20 minutes to complete one cut, to complete one cut, and average turning time is 5 minutes. Average turning time is 5 minutes. So cycle time will be 20 plus 5 is equal to 25 minutes. So in 25 minutes, one cycle will be completed by the surface miner. Now in one cycle, how much will be produced? Quantity of coal in one cycle. 200 meter is the face length. Width is 2 meter and depth is 0.25 meter and density is 1.4 ton. So this much ton will be produced in one cycle. 140 ton. So production per cycle is 140 ton and cycle time is 25. In 25 minutes, this much coal will be produced. So in 1 hour, how much coal will be produced? That you can calculate. So production per hour will be 140 into 60 divided by 25. Just in 25 minutes, 140 ton coal is produced. So in 60 minutes, how much coal will be produced? That is the answer. So that is 140 into 60 divided by 25. This is equal to 336 tons. So answer of this problem is 336 tons. So the surface miner will be able to produce 336 tons of coal in 1 hour. Okay, let us move to another problem. I'll take some 2, 3 problems on form. A centrifugal pump has a discharge rate of 2000 liters of water per minute against a total head of 200 meters. If the pump efficiency is 75%, the input power to the pump in kilowatt. It can discharge 2000 liters of water per minute against a total head of 200 meters. Efficiency is 75%. The input power to the pump in kilowatt will be determined. This question was asked in GATE 2014. So pumping capacity Q is 2000 liter per minute and 1 liter, okay, divided by 60 per second. It will become liter per second. This 33.333 liter per second is equal to 33.333 kg per second because 1 liter of water is equal to 1 kg. 1 liter is equal to 1 kg. So power required, just we have said mgh. mgh, yeah, joule per second. This is kilogram per second. Work done per second. Work done per second. 33.33 into 9.81. This is in Newton. Newton into 200. Newton meter is joule, and this is in second. Newton meter per second into meter. So it becomes joule per second. Joule per second is nothing but watts. So 33.33 kg per second into 9.81 to convert into Newton into 200. Height is 200. Up to a height of total height of 200 meters. So this much watt is the power required. This is equal to 65399.346 joule per second, or this is watt. Joule per second or watt. This much watts. Divide by 1000, you will get kilowatts. You will get kilowatts. This much power is required, but pump efficiency is only 75%. If the pump efficiency is 75%, so motor power will be 65.399 divided by 0.75 kilowatt. This is equal to 87.199 kilowatt. Okay, this is the answer. This question was asked in GATE 2014. Very simple question. Now let us take another problem on pump. In an open cast mine, a centrifugal pump is required to lift water at a rate of 60 liters per second to a height of 80 meters above the pump level. The vertical suction head is 4 meters. The total friction head, including shock and energy loss, is 10 meters. If the pump runs at an efficiency of 80%, the brake power of the motor is again same problem but in a different manner. Okay. Total effective head. The pump has to throw 80 meter above the pump level. 80 meter. Suction head is 4 meter, means water level is 4 meter below it. And the total friction head including shock and energy loss is 10 meter. Total loss is 10 meter of head. So total effective head will be 94 meter. You have to select a pump which can throw a water up to a height of 94 meter. That is total effective head. Now pumping capacity is 60 liter per second. 60 liter per second or 60 kg per second. This is the pumping capacity. And he is asking brake power of the motor. So power required for Q is equal to QGH or MGH. That is what I told you. It is 60 kilogram per second. G is 9.81 and total head is 94. This Newton, joule per second or Newton meter per second. Joule per second. This is equal to 55328.4 joule per second or watts. This is in watts. Divide by 1000, you will get kilowatts. 55.328 kilowatts. But efficiency of the pump is 80%. Only 80%. So brake power of motor is 55.32 84.05 is equal to 69.16 kilowatt. So 69 kilowatt motor is required to deal with this pumping capacity. Okay, now let us take another question. From an open pit sump, mine water is lifted using a 250-meter long straight pipeline laid along a gradient of 34 degrees. Now here pipeline is not vertical, it is inclined at a gradient of 34 degrees. The pumping rate is 500 gallon per minute and 1 gallon is 3.8 liter. Additional head loss due to pipe friction can be considered to be 10% of the head lifting. If an overall efficiency of 70%, the electric power consumed by the pump in kilowatt is. Again, same problem. Only thing here pipeline is inclined. In earlier two cases, pipeline was vertical. So if inclined pipeline is there, you convert it into equivalent vertical pipeline. So let us find out the total vertical. So first pumping capacity is 500 gallon per minute or 500 into 3.8 liter per minute. Now calculate per second. So 500 into 3.8 divided by 60 liter per second. This is equal to 31.67 liter per second, and 1 liter is equal to 1 kg. This is 31.67 kilogram per second. Okay, so this is the pumping capacity which we got per second. Now your pipeline is 250-meter long. Your pipeline is 250-meter long along state pipeline laid along a gradient of 34. Along the 34. So this is the vertical head, h is the vertical head. So h will be equal to 250 sine of 34 is equal to 139.8 meters. So vertical head is 139.8 meter, even though pipe length is 250 meter. Now head loss, additional head loss due to pipe friction can be considered to be 10% of the head lifted. So head lifted is 139.8 meter. So effective head will be 139.8 plus 10% of this, which is loss due to friction, plus zero point 0.1 into 139.8 is equal to 153.78 meter. So it means total head required for pumping the water is 153.78 meter. As we already this type of data was given in earlier problem is stateway, but here as the pipeline is inclined, so we have determined the effective head or vertical head, whatever you say. Now it is a simple problem. Q you know 31.67 kilogram per second. H you know G is 9.81. Power required will be power required for Q is equal to M 31.67 G 9.81 into H 153.78 joule per second. This means joule per second. So this is equal to 47776.78 joule per second or watts. So joule per second is nothing but watts divided by 1000, you will get in kilowatt, and here pumping efficiency is or motor efficiency is only 70%. So this divided by 0.7 and 1000, it will be kilowatt. So this will be the motor power in kilowatt. This is equal to 68.25 kilowatt is the answer. So this question was asked in GATE 2016. GATE 2016. So whatever data is given, sometimes pipeline part of the pipeline is inclined and part of the pipeline is vertical. But always we have to find out the equivalent vertical head only. Equivalent vertical head only, irrespective of length of pipeline. Irrespective of length of pipeline. Okay. So friends, thank you very much for listening me. If you have any doubt, you can please ask your teacher and he will convey it to me and then I will address your queries accordingly. Okay, thank you very much. Okay, over to Neeraj.
Thank you so much, sir. Thank you